Hello, dear children. Good morning. Today we are about to begin our very first class in physics. Before getting into the topic, I want you to take a second and listen to your surroundings. What do you hear, children? I think I can hear the ticking of the clock, people talking, etc. You might also hear some sounds from your surroundings, isn't it? The sound from the TV, your mobile phone, people talking, etc. The study of sound is one of the interesting topics in physics, and today we are moving on to a lesson, sound. Now, what is this phenomena called sound? In this chapter, we will be discussing about sound, its characteristics, various properties, then different applications of sound. What exactly is this phenomena called sound? Sound is a form of energy. When you switch on a bulb, you can see that it produces light as well as heat. So there are two energy processes which are involved when a bulb is switched on. One is heat energy, the other one is light energy. Likewise, sound is also a form of energy. Now, how does sound propagate? What do you mean by propagate? Propagate means to travel. So how does sound propagate? Sound travels in the form of waves. What do you mean by a wave? In order to find out what a wave is, we have to do a simple activity. For that, you require a string which should be tied on both the ends. Now, here I have a string which is tied on both the ends. What I'm going to do is, I'm going to pluck one end of the string and see what happens. What did you notice, children? When the string was plucked at one end, you can see that it started moving, and the movement also produces a sound. The string was fixed in the beginning, but when you pluck one end, it started moving. The movement was an up and down movement about a mean position. Mean position means a fixed position. So this up and down movement about a mean position or fixed position is known as vibration. And this vibration has produced a sound. Now there was a disturbance produced in the string, isn't it? Initially it was at rest. When you pluck one end, it was disturbed from its original position. This disturbance is known as a wave. So what is a wave? A wave is a disturbance which is produced in the medium. And how is sound produced? Sound is produced by the vibration of objects. The vibration of the strings of the guitar produces the sound. Vibration of vocal cords in human beings produces sound. So sound is produced by vibration. Now we have defined two things. One is the definition of sound and second one is the definition of a wave. Now one more thing, we have told that sound is produced by vibration. In order to study about sound, we have to study about waves in detail. There are mainly two types of waves. One is the mechanical wave and the other one is the electromagnetic wave. So, first one is mechanical wave. Mechanical wave is a wave which requires a medium for its propagation. So what do you mean by a medium? A medium is something which facilitates the transfer of energy. When I'm speaking, the medium which is surrounding me is a air, and the air molecules are the particles in the medium. So the particles in the medium vibrate to produce sound. Clear? So mechanical waves are the waves which require a medium for its propagation. Mechanical waves are divided into two: longitudinal waves and transverse waves. Sound waves are longitudinal waves, whereas water waves are transverse waves. We will see longitudinal and transverse waves in detail. Second one is electromagnetic waves. Electromagnetic waves are the waves which do not require a medium for their propagation, and they travel faster than mechanical waves. Example for electromagnetic wave is the light wave. Here, what you see is the electromagnetic spectrum, which consists of different radiations that are coming from the sun. So, the visible region is a small region. It is here. And there are several other radiations like gamma rays, X-rays, UV rays, infrared, microwave, radio, TV, etc. All these radiations come under the electromagnetic waves. Now, here you can see two figures depicting a longitudinal wave and a transverse waves. I've told you that mechanical waves are divided into two. They are longitudinal waves and the transverse waves. Now, here a person is pulling a spring in this direction, and the spring moves back in this direction. So, you can see that a pattern is generated there. Here, the number of coils is more here. It is less here, more, less, more. Again, it is less, and it goes on. So, longitudinal waves has a peculiarity. That is, here the direction of propagation of the wave is moving in this direction, whereas the particles are also moving in the direction of the wave. So in a longitudinal wave, the particles of the medium propagate in a direction which is same as the direction of propagation of the wave. Clear? Now, what can you see when you look at the transverse wave? You can see that the direction of propagation of the wave is this direction, while the spring is moving up and down. Here it is up, here down, again up, down, and the pattern goes on. So, in a transverse wave, the particles of the medium propagate in a direction which is perpendicular to the direction of propagation of the wave. The wave is moving in this direction, whereas the particles are moving up and down. So they are at 90 degree to the movement of the wave. So what is the difference between a transverse wave and a longitudinal wave? In a longitudinal wave, the particles are moving in the direction of propagation, whereas in a transverse wave, the particles are moving in a direction which is perpendicular to the direction of propagation. In this class, we have studied what sound is, how to define sound. Sound is a form of energy which produces the sensation of hearing, and it is produced by vibration of objects. We have also defined what a wave is. A wave is a disturbance which is produced in the medium. Then we have told about the types of waves, and they are mechanical waves and electromagnetic waves. Electromagnetic waves are the light waves, and longitudinal waves and transverse waves are the two types of mechanical waves. I hope you have understood. Thank you.